right, 2.6 notes. We're going to talk about transformations of graphs. So we're going to go through each slide, kind of talks about what it'll look like for each reflection. Up top in the right-hand corner of the first page, bless you. This is what it would look like if you had like all the transformations in one. So this is kind of helpful to have to help you maybe do your homework, to kind of help you memorize all the transformations. It's just memorization. So if we have a negative being multiplied on the outside, that's a reflection on the x-axis. If we have a number being multiplied on the outside, that would be either a vertical stretch or compression, and we'll go through an example of each. Inside our parentheses, we have horizontal things happening. So if we are multiplying a negative on the inside, it's a reflection over the y-axis. If a number is being multiplied on the inside, it's either a horizontal stretch or compression. And if we have a number being added on the inside, we're moving horizontally, which is left or right. And then if we are adding a number on the outside, we are going up or down. So first thing we're going to look at is reflections. If we have a negative being multiplied outside of our parentheses, so outside would look like if we had a negative outside of our parentheses squared, or if we had a negative outside of a square root, or a negative outside of absolute value. So it can look like any one of these three things, or anything, any type of function where we would have parentheses or boundaries where we have a negative on the outside. That is a reflection on the x-axis. If we have a negative being multiplied on the inside, it would look like negative x or negative square root of negative x, something like this where the negative's clearly inside. That would be a reflection on the y-axis. So all of this stuff shouldn't be new for you guys. We talked about this in Algebra 2 last year. When I taught it in Algebra 2, I would always say that you want to keep your ex-boyfriends outside of your house. So if you have a negative on the outside, it's the x-axis. Just think x is outside. Whatever it takes to remember it. If we are adding outside of our parentheses, that would be a shift up or down. So if we're adding, it would be up. If we are subtracting, it would be a shift down. So we would just take our whole graph and shift it either up or down, depending if we are adding or subtracting. If we are adding or subtracting inside the parentheses, inside, if we are subtracting, we are moving to the right. And if we are adding inside, we're moving to the left. So remember, inside the parentheses is always the opposite of what you would think. I like to think about it as plus and left. Left kind of looks like it has two plus signs in the word. So plus means left. That is inside parentheses. If we are multiplying by a number outside, that is either a vertical stretch or shrink. Sometimes you might see the word compression. Compression is the same thing as shrink. The book uses shrink. I think WebAssign uses shrink too. But you might see compression. Compression and shrink, same thing. So if we are multiplying a number and that number is greater than 1, it is a vertical stretch. If we're multiplying a number and it's in between 0 and 1, so it's something like a fraction, like 1/2, or a decimal, like 0.8, that would be a shrink. And when it's outside, it's vertical. When you're multiplying inside the parentheses is the opposite of what we think, and it's horizontal. So if it's greater than 1, we have a horizontal shrink. If it's in between 0 and 1, it would be a horizontal stretch. And then to find the factor of what we are shrinking or stretching by, we take the reciprocal. So when it's horizontal, To find the factor, you take the reciprocal. Which we'll do some examples where you see. But if we are shrinking, if we have a horizontal shrink, and we are multiplying inside by a number, it would be 1 over that number. So we're going to practice some examples of each now. So when I'm adding on the outside, notice here how I don't have any parentheses, so this is considered outside. If I'm adding on the outside, which direction am I moving? Up 3. If I'm subtracting on the outside, which direction? Down 2. Perfect. The WebAssign is like 37 questions-ish, but a lot of them are like this, where it's just quick. No math required. So again, this section's a lot of memorization. So a lot of just looking at it and identifying how it's moving. On the next page, if I'm adding 4 on the inside, which direction am I going? Left 4, perfect. And if I'm subtracting 3 on the outside? Down 3. Awesome. For B, if I'm subtracting 2 on the inside? Right 2. And adding 7 on the outside? Up 7. Awesome. For A, on the next page, we are multiplying by a negative on the outside. So again, there's no parentheses here. So if there's no parentheses, no square roots or anything, it's implied that it's outside. So if we're multiplying by a negative on the outside, what does that mean? A reflection on the x. Reflection on the x-axis. What about multiplying by a negative on the inside? Reflection on the y. Awesome. Next, for A, I'm multiplying a number outside that's greater than 1. Vertical stretch, perfect. For stretches and shrinks, you need to identify if it's vertical or horizontal. So here we have a vertical stretch because it's greater than 1. What about if we were multiplying on the outside by 1/3? Vertical shrink. And here the factor that we're multiplying by, the factor of the stretching and shrinking, is the same as the number. So it'd be a vertical stretch by a factor of 3. And then the second one would be a vertical shrink by a factor of 1/3. On WebAssign, I think a lot of the questions are multiple choice, so it'll say it. But it might have, like, an option might be a vertical stretch by a factor of 3 or a vertical stretch by a factor of 1/3. So, like, it's important to know. Questions here? Right, next. For A on 7, we are multiplying on the inside by 2. So remember, inside is the opposite of what we think. A horizontal, what? Shrink. Inside is horizontal and it's the opposite. So if it's a number greater than 1, it's a shrink. Horizontal shrink by a factor of, here we have to take the reciprocal of it. So if it's 2 over 1, what would the reciprocal be? 1/2. Chloe?
So is that parentheses instead of 1?
Yes. Next, we're multiplying the inside by 1/2. What type of transformation do we have here? Horizontal stretch by a factor of 2. Perfect. So we take the reciprocal of 1/2, which would make it 2. So when it's inside, it's horizontal which means the opposite of what we think, and we have to take the reciprocal.
For anything that's inside, do you always have to flip it?
Like when you're adding inside, we say that it's the opposite of what you think, because when you're adding, you almost want to think that it goes right in like the positive direction, but when you're adding, you go left.
No, I'm saying like how we have to, like for,
But that's just like, yeah, anything that you're multiplying inside, you want to flip it.
okay.
So for both of these. Questions here? All right, on the right side of the page, we are going to identify all the transformations. So in number 1, what's the first transformation that we have?
Reflection over the x-axis.
Awesome. That negative is a reflection on the x-axis. Perfect. What about multiplying by 1/3 on the outside? Vertical or horizontal? Vertical shrink by 1/3. What about adding 7 on the inside? Left 7. And subtracting 1 on the outside? Down 1. Awesome. Good job. All right, for number 2. So that 2 being multiplied on the outside does what to our graph?
Stretches it? Vertical.
Vertical stretch. What about multiplying by a negative on the inside?
Horizontal shrink.
Reflection over the y.
The negative is a reflection. So you got to treat the negative and the number as they're two separate things. So this is a reflection on the y. And then the 3 on the inside does what? Horizontal what? Horizontal what? Shrink. Remember, when it's on the inside, it's the opposite of what we think. Horizontal shrink by a factor of what? 1/3. Then if we're subtracting 4 on the inside, to the right 4. And adding 5 on the outside, up 5. Right, next we're going to talk about even and odd functions. So we can determine if a function is even, odd, or neither by plugging in a number and its opposite, and by taking the answer and seeing what we get. If we get the same number as the answers, then it's an even function. If we get opposite numbers as the answer, it's an odd function. And if we get two numbers that are totally different, then it would be neither. So to determine if it's even or odd, we plug in a number and its opposite. But it has to be greater than 1. So 90% of the time I would recommend plugging in like 2 and -2, just because it's going to be nice small numbers to work with. But you could plug in, if you wanted to, 7 and -7, and the same rules are going to apply. You'll end up with the same answer if you do the math right. I just probably wouldn't recommend picking a number so high, but I would just stick to 2. So in example 8. We want to determine whether the functions are even, odd, or neither. So if they're even, we're looking to have the same answer when we plug in a number and its opposite. If they're odd, we're going to have opposite answers. And if they're neither, they're going to be two totally different numbers. So for A, I'm going to stick to plugging in 2 and -2. So I'm going to start by plugging in 2. Let's find f of 2. So I have 2 to the 5th power plus 2. What's 2 to the 5th power? 2 times 2 times 2 times 2 times 2.
32.
Awesome, 32. And 32 plus 2? 34. Now let's plug in negative 2. So I have negative 2 to the 5th power plus negative 2. What's negative 2 to the 5th power?
32.
Negative 32. And negative 32 minus 2? Negative 34. So we have the same number, but opposites, because I have a positive 34 and a negative 34. So this would be odd. Let's do the same thing for B. Again, you can plug in any number you want and it's opposite. So you could plug in 3 and negative 3. I would just say that like taking the 4th power of 3 might be a little bit harder than taking the 4th power of 2. So I would just stick with 2. So we have f of 2, which would be 1 minus 2 to the 4th power. What's 2 to the 4th power? 16. What's 1 minus 16? Negative 15. Let's plug in negative 2 and see what we get. So f of negative 2 with 1 minus negative 2 to the 4th power. So 1 minus, what's negative 2 to the 4th power? 16. And 1 minus 16? Negative 15. So we get negative 15 and negative 15. What does that tell us? Even. They're the same number, so it would be even functions.
Wait, why are you plugging 2 and negative 3?
Just to see if it's even, odd, or neither. That's how we test it. So you want to plug in a number and its opposite. It has to be greater than 1, but you can pick any number you want. I picked 2 just because it's going to be the easiest math to do. So let's do C. So we can plug in 2 and negative 2. Let's start by plugging in 2. We get 2 times 2 minus 2 squared. 2 times 2 is 4 minus 4, which is 0. Let's plug in negative 2. F of negative 2. We have 2 times negative 2 minus negative 2 squared. Negative 4 minus 4. What's negative 4 minus 4? Negative 8. So what can we tell about our two numbers? It's neither. They're not the same number and they're also not opposite. So this would be neither. It's not always going to be like whether the exponent is even, odd, or neither. But you're not going to have all odd exponents and your answer be even. But I would just plug in a number to test it each time. And just be careful with the math. Just follow your order of operations. It's easy to get mixed up on a sign and then get the wrong answer here. So just be careful when doing the math.